students, I am Dr. Stuti Singh from ABES Engineering College, and my department is Applied Sciences and Humanities. So now we are going to continue with the wave optics part 1, and in this lecture we are going to talk about, we are going to talk about interference in wedge shape film. Before we talk about interference in wedge shape film, in the last lecture we derived the condition of maxima and minima for interference in thin film, and we were just discussing about the reflected and transmitted light. Okay, so we discussed about the reflected light. Now here we are going to discuss about the transmitted light too in very short manner, and we will see how they are complementary to each other. So in interference in thin film, reflected system and transmitted system are complementary to each other. Okay, so now let us see the parameters for both. First, we will be talking about reflected system, and then transmitted system. See, so for reflected system, what is the diagram if we remember? The diagram is there is a parallel thin film. The source, the light is incident on the thin film. The light gets reflected as ray 1, and then it is refracted inside. From the lower surface, it is reflected and emerge out from the upper surface. This is ray 2. The interference is occurring in the reflected rays, right? Over here. Suppose the T is the thickness of the thin film and mu is the refractive index. And if we talk about transmitted system, in transmitted system, again, if we take the parallel thin film of T thickness and mu refractive index, so we know that rays are also transmitted from the thin film. Okay, so how we can show the diagram that the ray from the source, the light is incident on the thin film. And now we are going to talk about transmitted rays. So now let me draw the diagram of transmitted rays. See, and the light will be transmitted from here and here. So now over here in transmitted system, this is ray 1 and this is ray 2. So if we calculate the path difference, as we calculated in the last lecture for reflected system, here we are directly going to write for the transmitted system. So if we calculate the path difference, in this case, the path difference is 2 mu t cos r plus minus lambda by 2. And in this case, this is for reflected system. In this case, the path difference for transmitted system is 2 mu t cos r. Because in reflected system, ray 1 Stokes law occur. But in transmitted system, there is no such ray that is, just touching the denser medium and reflecting. So this is the difference between the path difference of both. So in this case, what is the condition of maxima? The condition of maxima is 2 mu t cos r is equals to 2n plus minus 1 lambda by 2. Okay, and the value of n depends that we are taking plus or we are taking minus. Here, in the case of transmitted system, the condition of maxima is given by 2 mu t cos r is equals to n lambda. Okay, and here the condition of minima for reflected system is given by 2 mu t cos r is equals to n lambda. In transmitted system, the condition of minima is given by 2 mu t cos r is equals to n plus minus 1 lambda by 2. Now see, complementary means just, suppose if the fringes are forming, so in reflected system, where, where the bright fringe is forming, in transmitted system, at that place the dark fringe will form. Because we see that in both the cases, the condition of maxima and condition of minima, they are same. If the condition of maxima of reflected system is 2n plus minus 1 lambda by 2, so condition of minima of transmitted system is 2n plus minus 1 lambda by 2. Okay, so condition of minima, it is 2 mu t cos r is equals to n lambda. Over here the condition of maxima is this condition, 2 mu t cos r is equals to n lambda. So they are just opposite and they are known as that they are complementary to each other. So this is the meaning of interference in thin film when we talk about reflected and transmitted system, and and we say that they are complementary to each other. Okay. Now further we are going to talk about interference in wedge shaped film. Okay, now wedge shaped film. What is the meaning of wedge? Let us see. See, a wedge shape in thin film, we say about the wedge shape, then now we are going to talk about wedge shape film. So what is a wedge shape film? In wedge shape film, the two surfaces of the thin film, they are inclined to each other, making an angle theta. So now let us draw the diagram for the wedge shape film. Let me select the pen. Okay, see. This is a wedge shaped thin film, AOB. Now, over here, like previously we talked about thin film that was having uniform thickness. It was a parallel thin film. Now over here we can see that the two surfaces are inclined, making an angle theta. So when the light will be incident on the surface, upper surface, it will reflect from the upper surface of the thin film. Again, it will refract inside, and after reflecting from the lower surface, it will emerge out. So over here, ray, this is ray 1 and this is ray 2. And the interference will occur between these two rays, as from a single source. What is happening is, from a single source, there are two coherent sources produced due to the division of amplitude. Okay. So if we draw the normal and derive the relation of path difference, what path difference we will get is, if considering that the light incident on the thin film is, it falls normally. So if it is falling normally, then what will be the path difference in the case of wedge shape film? It will be 2 mu t plus minus lambda by 2. Okay, because the value, as the light is falling normally, we are considering, so the value of r will be 0 and cos r will be 1. Okay, so in this case, what will be the condition of maxima? What is the meaning of maxima? Bright fringe. And what is the meaning of maxima? Constructive interference. Again, it will be 2 mu t is equals to 2n plus 1 lambda by 2 or 2n minus 1 lambda by 2. And what will be the condition of minima? Condition of minima will be 2 mu t is equals to n lambda. Okay. So now further what we will do is we will be calculating for the fringe width of the fringes that are forming due to the interference in wedge shape film. Now theoretically we have seen the value of uh, path difference that is there between the ray 1 and ray 2. Okay, so if we consider the condition of maxima and minima, we see that it is 2n plus 1 lambda by 2. So the value of n starts from 0, 1, 2, 3 over here. And in this case, the value of n starts from 1, 2, 3, and so on. And in this case, the value of n starts from 0, 1, 2, 3. Okay. Now, just seeing the condition of maxima and minima, if we write this is equation number 1, suppose this we can take both as equation number 2, and this we can take as equation number 3. So with the help of one of these equation, we can also solve the fringe width of fringes that are being formed due to the wedge shape film. Now let us see the derivation for fringe width. So I'm taking the subtopic as fringe width. So what is a fringe width? It is the separation between the two successive bright fringes or between two successive dark fringes. Sorry, just dark fringes. And it is denoted by omega. Okay, so what is fringe width? It is the separation between the two successive bright fringes or between two successive dark fringes. Now let us see how we can calculate the value of fringe width. Let us draw the diagram. Suppose this is a wedge-shaped thin film, AOB, and making an angle theta. Now suppose this is T1 thickness and this is T2 thickness. So at T1 thickness, there is as nth dark fringe with the distance xn from the edge. And at T2 distance, there is n plus 1th dark fringe at the distance x n plus 1 distance. Okay. So if we see, now this is the diagram. So what we are considering is let xn be the distance for nth dark fringe. okay, from the edge. So here, what if from the diagram, what we can find out is, what is the value of tan theta from here? Very right, students, it is T1 upon Xn. Or what is the value of T1 from here? T1 is Xn tan theta. So this is equation number 4. Now, if we put this value of equation number 4 in equation number 3, that condition of minima for the case of wedge shaped film. So what will happen? Putting the value of T1 from 4 in 3. So what is it? 2 mu T. So in place of T, what we have to write down? In place of T, we will be writing down T1. And what is the value of T1? The value of T1 is Xn tan theta. So I'm writing this value of T1. So it is 2 mu Xn tan theta is equals to the condition of minima is n lambda. Okay, this is equation number 5. Now let us move further. Now similarly, for the distance xn plus 1 or for n plus 1th dark fringe, for n plus 1th dark fringe at distance xn plus 1. So what will be the condition if we put the value of, T2 from the diagram, that tan theta is equals to T2 upon xn plus 1. So what will be the value of T2? The T2 will be equals to xn plus 1 tan theta. Again, substituting this value of T2 in equation number 3 or condition of minima. What we get is, we get substituting the value of T2 in equation 3. So what we get is 2 mu xn plus 1 tan theta is equals to n lambda. Okay, so this is equation number 6. Now what we will be doing, we have to find out the separation between the two fringes. Okay, over here we have considered the dark fringes. So let us subtracting equation 5 from equation 6. What we get? We get that 2 mu x n plus 1 minus xn is into tan theta. Just to tan theta is equals to lambda, right? So from here, what we get the value of xn plus 1 minus xn. We have to find out the separation between the two dark fringes. So what is the separation? Xn plus 1 minus xn, that is equals to lambda upon 2 mu tan theta. And so tan theta is nearly equals to theta, as theta is very small. Okay. So what is the formula now? Xn plus 1 minus xn is equals to lambda upon 2 mu theta. That is equals to omega. So omega is equals to lambda upon 2 mu theta. So this is the derivation of fringe width. Omega is equals to lambda upon 2 mu theta. Okay. So it is clear from the derivation that the interference fringes are equidistant from one another, right? Okay. And it is also an important formula for numerical point of view. Okay. So now in the next lecture, we will be talking about Newton's ring. Thank you, students.